Hello, so I'm going to do the review for the solutions test. I'm going to at least do some of it. So I guess without further ado, we can start the fun. So for percent by mass, the problem says a solution contains 3 grams of solute dissolved in 50 grams of water. What is the percent by mass of the solute in the solution? So our equation is percent equals grams of the solute divided by grams of the solution. So that would give us 3 grams divided by 3 plus 50. So 3 divided by 53. And I'll get my handy dandy calculator. And that gives us 0.0566, and we're going to times that by 100 to get a percent. And we get 5.7%. Percent by volume is very similar. We have a solution contains 5 milliliters of alcohol dissolved in 80 milliliters of water. What is the percent by volume of alcohol? So once again, we're going to take our percent equals milliliters of solute divided by milliliters of solution. So we get 5 milliliters divided by 80 plus 5. And my handy dandy calculator says 5 divided by 85 equals 0.0588 times 100. And that equals 5.9%. So for molarity, we have what is the molarity of 5.4 liters of a solution that contains 213 grams of sodium chloride. So our equation for molarity is molarity equals moles of solute divided by liters of solution. So first we need to solve for moles. We have 213 grams NaCl. 1 mole equals, let's see, we have 23 plus 35.5. So we have 58.5 grams. Do that in the calculator. We get 3.64 moles, and we can divide that by our 5.4 liters of solution. And that gives us 0.67 molar NaCl. For our second molarity problem, it says what is the volume of 2 molar potassium iodide containing, what volume of 2 molar potassium iodide contains 10 grams of solute? So we're kind of doing the reverse now. So we're going to put 2.0 molar equals X. Actually, we're going to first convert our 10 grams to moles. So 10 grams and 1 mole. Now our potassium iodide is 39 plus 127, and that's going to give us 166. So 10 grams divided by 166, we get 0.06 moles. So now we can put this in here, and we're going to look for the volume. So when we do this, we get 0.06 divided by R2, and that equals 0.03 liters. Next we have molality. What is the molality of a solution that contains 0.124 grams chromium dissolved in 43.5 grams of iron? So our molality equals moles of solute divided by kilograms of solvent. And let's see what we get. So we have 0.24 grams, 0.124 grams of chromium, and we need to convert that to moles. So 1 mole equals 52 grams. So we'll take 1.24 divided by 52, and we get 0.00238 moles. Now we can take that and divide it by our grams. Sorry, we're going to convert it to kilograms. So we have 0.0435 kilograms of iron. And that gives us a molality of 0.0548 molality. Next molality, it says how much gold can be dissolved into 50 grams of iron in a 1.2 molal solution. So I have 1.2 equals X over 0.050 kilograms. I just changed the grams of iron to kilograms. So when we solve for X, we get 1.2 times 0.050, and that equals 0.06 moles. And it wants to know how much gold can be dissolved. So you can either leave it as 0.06 moles, or we can switch it to grams, which is fine. So 1 mole is going to 197 grams, and that gives us 11.82 grams. So either answer is fine. Let's take a look at our mole fraction. So for mole fraction, we have to get moles of each part. So a gas mixture contains 35 grams of CO, 65.2 grams of Cl2, and 87 grams of N2. And it wants to know what is the mole fraction of carbon dioxide. So first we need to get moles of each. So 1 mole of carbon monoxide, we have 16 plus 12, it's 28 grams. So 35 divided by 28 equals 1.25 moles CO. Our chlorine, we have 35.5 times 2, so that's going to be 71 grams in 1 mole. 65.2 divided by 71 gives us 0.918 moles Cl2. And our nitrogen, N2, that's 14 plus 14, so we have 28 grams in 1 mole. So 87 divided by 28 gives us 3.11. So now we're looking for carbon dioxide. So we're going to do 1.25 moles divided by 1.25 plus 0.918 plus 3.11. So 1.25 divided by, and then make sure you use parentheses on the bottom, 1.25 plus 0.918 plus 3.11, close parentheses, and that gives me a mole fraction of 0.237 or 0.24. The next mole fraction says a gas mixture contains these gases with the mole fractions. So we have xenon with a mole fraction of 0.019, argon 0.24, and Ne, so neon. And we don't know what that is. Wants to know what is the mole fraction for neon. So they all have to equal 1 for a mole fraction. So we can do 1 minus 0.19 plus 0.24. And that difference is going to be the neon. So we have 0.019 plus 0.24. So that gives us 1 minus 0.259. And we get 0.741 as the mole fraction for neon. So diluting solutions. Says I have a 6 molar stock solution of Ki. I need to make 250 milliliters of a 2 molar solution. How much of the original stock solution would I need? How much water would I need to add to it? Alright, so this is a dilution. We're going to use our M1V1 equals M2V2. So our starting concentration is our 6 molar stock solution. We want to know how much of that we need to make 250 milliliters of a 2 molar solution. So we have 250 times 2 divided by our 6, and that gives us X equals 83.3 milliliters. So this is what we would need to use of the stock solution. Now the second part of the question asks how much water would I need to add to it. So if our final volume is going to be 250 and we're have to put in this much, the difference will be how much water. So we take 83.3, subtract that from 250, we get 166.7 milliliters of water needed. For the second diluting, it says I need to turn 20 milliliters of a 0.4 molar stock solution into 0.25 molar solution. How much will I need to make? So we're starting with 20 milliliters. Sorry, let's get this right. 20 milliliters of a 0.4 molar stock solution, and we want to turn that into 0.25 molar solution, and we need to know how much will we need to make. So we have 20 times 0.4 divided by 0.25, and that equals 32 milliliters. So that would be the final volume. Next we have concentration, and our concentration is just going to be our 24 grams of sugar divided by, let's see, the total, which is 24 plus 250. So we have 24 divided by 274, and then we're going to times that by 100, and that'll give us 8.76%. This is for concentration. Our next concentration says I need to make a 42% solution of Ki. If I have 20 grams of Ki, how much water would I need to dissolve it in to make 42%? So I'm going to take and set up my problem. I have 0.42 is going to equal 20 grams of Ki, and then we have X plus 20 grams. So I'm going to take and multiply this whole thing on each side. So I get 0.42 times X plus 20 equals 20 grams. Now I'm going to distribute 0.42x plus, let's see, we have 0.42 times 20. That gives us 8.4, and that equals 20. So I'm going to subtract my 8.4. 20 minus 8.4 gives us 11.6. So we have 0.42x equals 11.6. Divide by our 0.42. And that gives us an x equaling 27.6. So 27.6 is how much water you would need. And that's in grams. Our next concentration problem, we have how much water is used to dissolve 50 grams of sugar to make a 3.4% solution. So we have 0.034 equals 50 grams over x plus 50. So it's the same as the other one. I'm going to multiply both sides by x plus 50. And that gives me 0.034x plus 50 times 0.34. 50 times 0.034 gives me 1.7 equaling 50 minus 1.7. That gives me 0.034x equals 48.3. Divide. Let's see. 48.3 divided by 0.034. That gives me an x of 1,420.6 grams. So this is how much I would need to dissolve 50 grams. See our next concentration problem. What is the mass of a 15% aqueous solution that contains 42 grams of alcohol? So we have 0.15 equals 42 grams divided by x plus 42. Same process, multiply each side by the x plus 42, so I have 0.15x plus 42 times 0.15, 6.3 equals 42 minus, let's see, 42 minus 6.3. So we have 1.5x equals 35.7 divided by 0.15. And that gives us 238. So x equals 238. Now it says this is the mass of the solution. So we would have to add, because this is just the solvent, we would have to add the 42 grams to get the solution. So it'd be 280 grams would be the total. So you need to have both of those. Alright, we're making progress. Let's flip to the back. These are what we've just been going over. So writing formulas, this you just need to be looking at your reference sheets. So writing formulas, for this you're going to look at your common ion charges. So ammonium chlorite, so if you look up ammonium, that's NH4 plus. Chlorite is ClO minus, and that gives you NH4ClO, because this is +1 -1, and remember when we cross our charges, they become the subscripts. For cesium ferrocyanide, we have cesium, which is +1. Our ferrocyanide is FeCN6 4+. Now if we cross charges, that gives us CS4 FeCN6. Auric chromate. So auric is gold. That's Au 3 plus. Then we have our chromate, which is 2 minus. And we can cross the charges. And that's going to give us Au2, CrO4, and we need to use parentheses and put a 3 because we have the 3 from the gold. Our bismuth binoxalate, we have Bi 3 plus. Our binoxalate is HC2O4, and that is minus. So this one goes down here, this one goes down here, and that gives us all right, naming formulas. So this is the reverse. So we have Cu HPO4, so you're going to find Cu on your chart, and that one, because our formula is HPO4, if you break this up into its ions, since this doesn't have a, you need to know the charge on this to find out how to name it. So look up the charge for HPO4 since it's only going to have one charge. It's not a transition metal. So this is going to be hydrogen phosphate. And whatever the charge is on this ion, since there's no brackets here, you know they have to be the same because they cancel each other out. And when you look at your sheet, the one that corresponds with the correct charge is cupric. So cupric hydrogen phosphate. Now we have magnesium, so Mg O3 2. So if we know that this 2 went with this, and since there's nothing down here, that would be a 1. So we have magnesium. And look up IO3 on your chart, and it says it is iodate. So we have magnesium iodate. Alright, so the next one we have, just ignore this, is going to be our SN3 P4. So when you look at SN, and this must be the charge that was on the SN because we have a choice between tin 2, which is stannous and is SN plus 2, and tin 4, which is stannic and it's SN plus 4. So if this was the charge, we'd have SN plus 4. So we can say it was tin 4, or we can say it's stannic. And then this charge must have been here. And if we look up that, P3 minus is called phosphide. So we would have tin 4 phosphide or stannic phosphide. The next one we have V4 SiO4 3. So if we look up SiO4, the charge on that is where this 4 comes from, so it's actually a negative 4. And vanadium, the charge on vanadium is 3 plus. So we have vanadium, and there's only one, so for vanadium it's always 3 plus, so we don't need to write anything else. And then SiO4 is called silicate. So we have vanadium silicate. For chemical equations, it says silver nitrate and sulfuric acid. So we have silver nitrate and sulfuric acid. So let's write these out. So silver is Ag plus 1, and nitrate is NO3 minus 1. So we're going to get AgNO3 plus sulfuric acid, which is H2SO4, and this is on your common chemical compound sheet, which you'll be given on the test. And then we need to figure out what are they going to make. So we're going to switch pairs. So we're going to have silver sulfate and H2NO3. Now when we look, we'll write these first. So Ag is plus 1 and SO4 is 2 minus, so we're going to have that 2 come down to the Ag and SO4 plus our H, and H is plus 1, NO3 is minus 1, so we have HNO3, that's nitric acid. And now we need to balance it. So we have 2 hydrogens over here, so I'm going to put 2 here. We have 2 silvers here, I'm going to put a 2 here, and now it balances because we have 2 NO3. Alright, so that is what it wants you to do when writing the equation. So start by writing out the products, and then these are going to be double replacements, so just go ahead and switch partners for the products. Number 2, mercuric sulfate and potassium hydroxide. So mercuric sulfate and potassium hydroxide. So mercuric, if you look on your sheet, is Hg2+, and sulfuric is 2-, so we just get HgSO4 plus potassium hydroxide, which is KOH, and that's going to give us, when we switch, we're going to switch partners, so mercury is going to go with the OH, sulfur is going to go with the potassium, so we get HgOH2, because remember Hg has the plus 2, plus our potassium, we always write the positive one first, K2SO4. And now we need to balance, so we have 2K here, I'm going to put 2 there, 2 OH here, 2 OH here, 1 mercury, 1 mercury, 1 sulfate, 1 sulfate. So we're good. 3 says sodium carbonate and lead nitrate. So sodium carbonate, our sodium is plus 1, our carbonate is 2, so we have CO3 plus lead, which is a plus 2, and our nitrate is a -1, so we have PbNO32. And when they switch partners, we get sodium nitrate plus lead carbonate. And since the lead is +2 and the carbonate is -2, we just have PbCO3. So now check the balance. I have 2 sodium here, I need 2 here. That gives me 2 nitrate, 1 lead, 1 carbonate. So I'm good. Now it says complete ionic equations for the ones above. So we have complete ionic equations. The complete ionic equations is just breaking up the compounds. So here are our compounds. So we're just going to break them up into their ions and write everything out. So for 1, we have 2Ag because we're going to have a balance. Got to put the charge. Plus 2NO3, 1 minus, plus 2H plus SO4, 2 minus, and that's going to give us Ag2SO4. So this is your precipitate. So when you check the products against your solubility chart and see if this makes a precipitate or if the other product makes a precipitate. Since this one does, we leave it together and write S. And then we have 2NO3 and our 2H plus. Alright, I'm going to skip down to where it says net ionic equation. So it wants you to do the net ionic equation next, and that one is just going to be only the stuff involved in making this. So Ag is involved and SO4. So I can cross out our spectator ions, and when I rewrite it, I'll have 2Ag plus SO4 2 minus gives me Ag2 SO4 solid. So this is the net ionic. Just the items involved in making the precipitate. So for number 2, I have Hg2 plus SO4 minus 2 plus 2K plus 2OH minus, and that's going to give us, now I check these, and mercury hydroxide is not soluble, so it's going to be our solid. And then we have potassium and our sulfate. Now for the net ionic equation, we only care about the ones that make this. So we don't care about this one, we don't care about this one, they're spectators. So our net ionic equation is Hg2 plus 2OH minus gives us HgOH2. And that will be solid. And number 3 is going to be 2Na plus CO3 minus 2 plus Pb2 plus 2NO3 minus gives us 2Na plus 2NO3 minus plus lead carbonate, which is our solid. And I'm going to do the net ionic equation, so we only care about the things that form that. So I can cross out the sodium and the nitrate. And my net ionic is going to be Pb2 plus CO3 2 minus gives me PbCO3 solid. So that was our complete ionic equations and our net ionic equations. And now our solubility. You need to use the chart that I gave you. It says name an ion that will precipitate with sulfide. So if you look at your chart, you're looking for the one that says not soluble. So not soluble equals precipitate. PPT means precipitate. So one that fits that bill could be Al3 plus. Something that will not precipitate with anything. So you look down the chart and find one that only says soluble. That means nothing will precipitate when mixed with that. And that one would be nitrates. You can add nitrate to anything and it will not form a precipitate. And then it says, will aluminum sulfide make a precipitate? So you're going to look for the sulfide ion. And when you look at it, I'm going to pull out my chart. If you look at the sulfide ion, it says, will aluminum sulfide make a precipitate? So we're going to look for the not soluble. So it says any other positive ion. Well, let's look at the ones that won't make a precipitate. We have alkali ions or ammonium. Well, that's not aluminum. And then beryllium, magnesium, calcium, strontium, barium, or radium. None of those are aluminum. So yes, aluminum is any other positive ion. So the answer is yes. And that is the review for the test. Hopefully that was helpful, and good luck studying.